This lesson is called Toughest Tower, and we're going to be examining forces and motion in this lesson. So it's going to be our introduction to sort of our physics unit, and the standard that it most closely correlates with is several that talk about how things near the surface of the Earth are pulled towards the Earth by gravity, but that's a bit of a stretch. Really, the point of this lesson is just to get kids thinking about the structure of a building, all right, and in this case the tower they're building, the structure of anything. You can take it all the way down to atomic structure, and how those structures can have the most strength. So, and again, I have to thank the people at the Integrated Teaching and Learning Program at the College of Engineering at the University of Colorado at Boulder, who gave me this idea in the first place in a lesson they called the Leaning Tower of Pasta. I've added some things to it, but the original idea to make the pasta and marshmallow towers came from them. And again, that was found at teachengineering.org, a fantastic resource. If you haven't seen that resource before, please do check it out. Alright, so the students are all going to need a worksheet that has Toughest Tower on it, and it's right below this video. It has information about their challenge day. They're going to be trying to build a tower that's at least 10 centimeters in height and can hold the most weight. That's their goal. Now, I really like to make this kind of a two-part experiment. The first part is the students working as a team to decide what materials they want to use. They have a budget. In this case, I gave them $40,000. And then each of the different materials is worth a different amount. So mini marshmallows are worth $500 a piece. Spaghetti, the thinnest of the pasta we're using, is worth $1,000 for each spaghetti noodle. Linguine, a little bit thicker, is worth $2,000 per noodle. And the fettuccine, which is very thick, is worth $3,000 per noodle. And so the teams are going to have to decide, all right, how are we going to balance our budget with the materials we want to use? And so I like them to have all of that math worked out on their sheet. I've got a space for them to work it out before I start the activity with them. If you're doing this as a classroom teacher, it might take an hour instead of 40 minutes if you add this math extension. Now, the really fun way to do this is for you as the teacher to run the local lumber yard and let students haggle with you a little bit. Maybe they'll bring back half of a fettuccine, that they didn't want to use, and you maybe trade it for one spaghetti noodle. That's up to you. I'll let you decide how you want to run that part of it. But it is fun if you're the lumber yard and you kind of, there's some haggling involved and some deal making. And it helps kids keep track of their math and think about, well, how much would half of a fettuccine actually be worth? Okay, with that said, once they have that part done, they've calculated, how many spaghetti noodles they want, how many fettuccine, how many marshmallows, they're going to get their supplies and they're going to start building their towers. Now, I'll tell you right now, this is a frustrating lesson for students. It is not easy to build a strong tower out of pasta and marshmallows. And I've seen time and time again, it's actually a really interesting thing to watch. Kids that would normally excel in school on worksheets, jumping through the hoops, can get very frustrated with this lesson very quickly. That's not always the case, but it does happen. And I've seen kids who normally would have no problems working in a classroom, be your top students, answer all your questions, get so mad that they've crunched up their tower and thrown it against the wall. A behavior that we might see in a student who is not so good at doing book work. Say they might throw their pencil against the wall out of frustration. So that's another way that hands-on science is really good because it lets us test kids' strengths in areas we may not otherwise test. So I've got an example of a tower I built earlier here. It's just a box. It's got lots of cross supports. That's going to be important. I'll talk to kids about that. You don't just want to have squares, you want to have triangles, because triangles are a much stronger shape than a square. So once the kids get it built, we'll make sure that it's at least 10 centimeters in height. This one is about 12, so it comes in above the threshold. And if you're working with upper level students or a little more advanced students, and you wanted to add another dimension to this, before the students test their towers, you could have them weigh them in grams. And that way, not only will we see whose tower is the strongest, but you could also compare, all right, whose tower was the strongest per gram? How many grams, did they hold compared to how much they weighed? Anyway, once it's built, then I've got just a piece of cardboard that has to sit across the top, so the students will have to know that in advance, know that their tower needs to hold that cardboard. And we're going to use pennies because they happen to be the cheapest weights that I can get. And basically a penny weighs somewhere around 2.5 grams. So we'll just add pennies until this thing breaks. And you're going to see towers hold no pennies all the way up to 200 or 300 pennies probably, depending on how the students built it. And another thing, let students put the pennies on themselves, and how they distribute the pennies is going to make a difference. This is a fun activity though, when you have groups in the room that can hold hundreds of pennies. And I would encourage them to just count them as they put them on, because sometimes once they fall, see mine's starting to fall here, once they fall the pennies can really go everywhere and make a huge mess. But if you build them well, okay, you can really hold a lot of pennies. And like I said, it's frustrating for some kids, but it's really a lot of fun to see the designs they come up with and how those designs do compared to others. And then it's a good way to start talking about structure, and even structure and function of living things if you want to, how are things built in a way that, allow them to be strong and accomplish the given task. So you can see kind of destroyed afterwards. You could always measure it afterwards too, weigh it afterwards. It's just sometimes you lose little pieces and some of the mass. So when they're done, I then have some math for them to do, total cost of the tower, height of the tower, and then how much the tower weighed, and they can then calculate the strength efficiency. How efficient was it compared to its mass? So this is a fun lesson, fun way to get into our physics unit, and I think good extensions for any sort of engineering challenge are to let students rebuild. Alright, you've tried it, you've seen how it went, let's do it again. Let's recalculate our budgets here, and let's see if you can do better the next time now that you've had some experience with it. That's the goal, right? We want students to try and try again and try again and try again and improve every time. Now that's kind of the whole purpose behind doing science, is to gain better understandings as we do these hands-on activities. So that's a pretty simple lesson, not much explanation there. Have the students do the math beforehand, run the lumber yard, and it's a lot more fun that way. If you choose, if you don't have time, don't have class time, you could just give each student a certain number of spaghetti, linguine, and fettuccine, and a certain number of marshmallows, but I think it adds a lot more thought, and it's a lot more fun when the students actually do the math themselves. One last thing is I do have a link to a game, a physics game, below this video called Demolition City. It has students putting dynamite different places on buildings to implode them, and that's another way to help students think about structure and what points of a building are more important for the structural integrity than others. Well, that's it for this time. We'll see you next time.